Hey, we got a another thing on the bench, on the healing bench this time. This is an Onkyo receiver, Onkyo brand. It is a an older one, a TX, down the bottom right hand corner, TX SA603. It's a bit of an older unit, but a friend's going to use it in his shed to play music and that sort of stuff. But it doesn't turn on. It just does not respond to the power button, bottom left hand corner there. It doesn't turn on at all. So I'm going to open up and have a look, see if we can fix it. I've had a little quick poke inside just to see if there's any blown fuses, and I couldn't find anything obvious like that. But I have found a schematic. This is the power supply section. This is actually for the TX SR603X. What we've got here is a TX SA603, but it's close enough. It's pretty much the same. So we're going to run through, see what we can find. If there's anything obvious, maybe a blown diode or something's going on. But the power button is actually running through all sorts of stuff, microcontrollers and stuff, because it's a standby button and not a hard on-off button as I was hoping. So this thing, when you plug it in, it immediately sort of powers up and goes into a standby mode. And then once you hit the standby button, the power, or the on standby as it's labelled, then it will fully power up. But that may give us a clue as to why it's not turning on at all. Maybe that standby power isn't working. So hopefully we can find it in here without having to delve too deeply. Alright, so here we are inside the unit. We've got our main power transformer here. Onkyo branded HCPS, high current power supply. We've got the input board, the main input board here, with a black box there. That's the relay that turns on this main power transformer, with a fuse and a filter capacitor just there. That fuse has been tested as okay. This is the mains cord coming into this plug. Down the bottom there you can see a little transformer, maybe right down in there. My finger's just pointing to it, wiggling around. That's our standby power transformer. So that's wired directly to the mains. So as soon as you plug this unit in, that transformer is in the circuit that's connected. So that's what powers up the standby system on this unit. Once you press the power button on the front, which you can see down the bottom here, that's the board there with the power switch on it. Once you press that, then because you got a little bit of power that's just running the microcontroller in like a basic mode, it will then turn on, and then turn on this relay and turn on the main power supply, and then the whole unit will come alive. That's the theory anyway. It's not actually happening right now. So what I'm going to do is I can actually pop some fuses, or not pop the fuses, but pop them out of the socket, pull them out of the socket, and isolate everything else except for that transformer down there. And then if I test here, I should get a resistance of that that winding, the primary winding. That will tell me straight away if that transformer down there is working or if it's not. So I have to pull out this fuse here. If I grab my tweezers, I should be able to just, yep, there we go. And there is one other fuse. It is a fuse. So I've just popped out either fuse 903 or 901. So you can see here what happens is there's our power plug. It comes in, around, there's a relay there. It comes down through fuse 901 and then into the transformer, which is just here. It comes back out the transformer and then back out the mains plug. Also you got this one here which has got a fuse coming down to an AC outlet, and that's just on the back, so you can have that. So when this unit turns on, it also turns on your DVD player or something, so you can power that through there. So you don't have to turn on a secondary device at the same time. It just comes on automatically. So if we pop that's the fuse we want to pop, 901. Then that will isolate this transformer, so we're not measuring that at all. Because we do have a capacitor there, so if we measure it, we might measure through that capacitor and stuff. So if we pop the fuse, it's all isolated. And then this here is the small standby transformer. So that the power comes in, comes around, goes through a jumper here. It just says J, what's that? 924, through the transformer, and then it comes out and straight out again. There's no switching or anything in between the power plug, the mains plug, and that small auxiliary transformer, that standby transformer. So that's what I want to test, because something either here or in here possibly isn't working. So there's a bridge rectifier here, a full bridge rectifier, a heap of other diodes and stuff, so maybe something there's gone bad. But if that is test good, we will apply power here and we can test on this plug to see if we're getting like got 10 volts there, 12 volts there, that sort of stuff. So we can check to make sure we're getting voltages. If we are getting voltages here, then we know something further down, because these all come through here, the power supply to PC board, and that's coming around to here, and then it comes out of this side into the where the microcontroller and stuff is. So let's give that a test and see what happens. Okay, so that fuse I popped out of here, this one here, nice ceramic fuse. That was the correct one to isolate this transformer here. So I've got this on ohms. We'll test the mains plug and we should see a resistance if that small transformer is okay. And we are getting 4.5k, so that seems pretty good. So that means that transformer is most likely okay. And that's a good thing, because I don't like when transformers go bad, because they can be difficult to find because they're very specific. They're often made for the device they're in and not just an off-the-shelf unit. Whereas if it's a bad diode or a bad transistor or capacitor, you can just get anything like just from DigiKey or from an electrical wholesaler and just stick them in. So it's much easier when it's a component rather than a big transformer, or a small one in this case. So the next step is we will find out where the connections are, where those where this connector is, and I'm pretty sure it's going to be right down in here somewhere. There is a grey cable coming out from underneath there from memory, and yeah, we'll test some voltages and hopefully we can find the problem there. Alright, so the connector we got to test is this one right down the bottom here, right at the end of my little pointer. That's where our connections are. So on the schematic, get it into view, there we go. So we've got MPU ground. You can see there's a thicker line here, that's our ground. And we've got plus 12 volts and plus 10 volts. So they're the two that we want to be testing. So we want to make sure we've got 12 volts and 10 volts, or thereabouts. So I'll get my probes right down in there very carefully. Oh, that's the black. And we'll see what we get. That one there, 11.9 volts, 11.5 volts. So it says it should be 12 and 10. So one of those is a little bit high, but that might be because there's not much load on it right now. Yeah, it seems like that's the 12 volts. The 10 volts is through a the 10 volts. Well, actually, that might be something, because the 10 volts looks like it comes through this. Where are we? There we are. So the 10 volts comes through this one here, which looks like some sort of regulator, whereas the 12 volts comes up over and around directly to this bridge rectifier just here. So the 12 volts should be a little bit, you know, it could be a little bit here or there, but the 10 volts, it should be 10 volts, really. Ground, there, adjust, input, output. So yeah, that's interesting. I might have a look at that, but we are getting a voltage, so I might have to start working my way further down here. Alright. So I've realised that the connector I was testing wasn't here. It was up here. That's that connector we tested just now. So we're getting voltage coming out of here. Also, all of this sort of stuff, there's extra stuff here that says NC. I don't know if you can, if I hold that up, you'll see it says NC there, not connected. And that matches up with these boards. There's certain components that aren't installed, so that's shown here as NC, so that's no worry. So it looks like that the two voltages, the 12 volts and the 10 volts, are actually connected through some jumpers together over here. So that makes sense why there's the voltages were very close, not 10 volts and 12 volts. They were both pretty much 12 volts, so that's fine. So the orange one here looks like to be the one we're interested in. So that comes around through to that connector that we tested. Then it comes off of that board here, onto the next board, which is the one underneath here. That is what I've got here. So it's coming in down the bottom here. It comes up and straight out of the board again. There's no other connections for the 10 volt line, the orange one. The yellow one just comes into here to some stuff over here that we don't really care about. Well, I don't think we're going to care about, not yet anyway. There's some voltage regulators here. We might have a look at those in a sec because they do some 5 volt stuff coming out up here, but it says 5 volt video, so I don't think we're really caring about that. That may be for the function where if you have this unit turned off, it'll do video pass-through. That might be what that's for there, but if we get stuck, we'll come back to that. But what I'm interested in is this one here, which I've got in 2 parts. We're coming into this board, which is the CPU board. It traces around blah 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 to here. This is what I'm interested in. This here is the main CPU, it seems. Up here, we've got the trace comes in, 8.9 volts it says. Then we've got a regulator, linear regulator, input, output and ground, I, O and G. If you, I'll hold that up just in case you can't see it. But you see there, it says 5.6 volts. And then we come up to this diode, and on the other side of the diode it says 5 volt CPU. So that diode's going to be dropping. It's going to be a silicon diode, so that's 0.6, 0.7-ish volts. So we're going from 5.6 to 5 volts for the CPU. If we're not getting power through here, we're not going to get a CPU powering up. So I'm going to test that regulator, make sure it gets 5.6 volts here. If that's good, we can come to the other side of this diode. That diode may be open circuit. We'll test that. And then if that's still bad, we've got a transistor over here and bits and pieces, so we can test all that to make sure we're getting stuff coming in where we have to on the CPU. So I'll go ahead and find that one and we'll see if we're getting our voltages. Okay, so I have found that voltage regulator, and if I tip this up, it is just right in there, just below the edge here in the shadow. It's kind of hard to get the light in there, but I'm going to give that a test, and we should, if it's working, we should have around about 12 volts coming in and then around about 5.6-ish volts coming out. That's plugged in and meter is on the display there. So if I test what's coming in, yeah, 11.56. So then what's coming out, not that one, 5.9 volts, 5.6, sorry, yeah, there it is, 5.6 volts. So that voltage regulator is regulating okay, so that's not the problem. Let's work our way down the chain, see what the next thing is. And just for a sanity check, we probably should have tested this before, but we'll test the power switch, make sure that's working okay. Looks good to me. No worries. Alright, so I've done a bit more testing, and if you look here, where are they? There's 2 diodes just there. Those tiny 2 little diodes there. On the bottom side is where the voltage regulator comes up, and coming out is goes to our CPU or whatever. That's the 5 volts for the CPU, and we are getting just over 5 volts on those 2 diodes. So those 2 diodes are okay. So that means there's 5 volts coming out and going into stuff, CPU stuff. Now I've also traced from the power switch, which is just in here. I tip that up. It comes through this ribbon cable to the front display board, and then right down back at the back here, it comes through this ribbon cable, this flat flex cable, into the board here. If I tip this up, oh, there's a lot of movement. No, I can't see that way. I'll have to turn it around. A bit of maneuvering. Alright, this will be better. So on this connector here, we've got the 12th terminal, or whatever, the contact in from the left hand side is that the power switch terminal. That comes through a little 4.7k resistor and into that CPU or that chip there. And I've tested that and that is working. So we're getting 5 volts to here. We're getting the power supply signal when we press a button. We're getting that signal to here, but nothing's happening. So I'm wondering if it's that. There might be something wrong with this board, or maybe with that chip. It's not as easy as I was hoping it would be. Pin 91, by the way, on this chip. On the schematics, it's slightly different. It tells me it's pin 123, because the schematics I've got is for a slightly different model, and it's got a larger chip with higher pin count. But I've traced this one to pin 91, and it's coming through, and I can test it on there, and then test it at the switch. Press the button, I can get continuity, and it seems to be within the ballpark of the resistors that are in line. So yeah, interesting. I'll have to keep digging a bit more, but it might come down to just a replacement board, which is a bit of a bummer, because I was hoping I could actually repair the thing, like replace a capacitor or a voltage regulator or a diode or something. But replacing that chip, it depends if that chip is is actually programmed, or if it's just a straight CPU or something, like just a chip that doesn't have any onboard memory. If it doesn't have onboard memory, we could replace it, but it depends on whether we can get it, and also depends on the cost of this entire CPU board, if we can get that as well. So I'll do a bit more poking, a bit more research, and once I've got some more news, we'll see what we can figure out. So I've taken the CPU board out. It's got a few other inputs and stuff on there. There's our CPU there. It's actually a M30624 MHP-253FP. It's got 384k of ROM and 24k of RAM, and it's a mask ROM chip. So even if I could find one of those, I'm not going to be able to replace it, because it won't have the program burnt into it. It'll just sit there and do nothing, because it's got to be programmed before it gets put in, or being a mask ROM when it's being manufactured, I guess. So yeah, I'm hoping that that's not bad. It will be a bit strange if it was, because you'd think there'll be some collateral damage. Well, that would be the collateral damage of something else going bad. But we got the voltages right, and yeah, it's a bit weird that the CPU will just go bad. Maybe it did, but what I also noticed was here. This is a 5.5 volt 0.22 farad backup battery, and you can see maybe there we've got a bit of muck on the board. It's gone rusty. I think it's leaked. So maybe that might be causing our problem. Maybe that's pulling it down, like pulling a 5 volt rail down, or doing something funky. So maybe we can replace that and see what happens. Or maybe just take it out of the circuit and see what happens. So what I might do is I'll pull that out, and that's going to be just backup. So when you turn it off and you turn the machine back on again, it'll retain all of its settings. You won't have to recalibrate and reset everything back up again every time you turn the thing off, or you lose power at least. So I might pull that out and check that there's no traces that are badly damaged. Maybe like a wire here or there might be bad, and that might be what's causing the problem. But yeah, I'll have a bit of a poke at that and see what I can figure out. Alright, so I've finished the repairs to this board. I'll zoom right in so you can see what I've done. So we've got the new super cap here. It's a different form factor. It's turned 90 degrees, but that's no big deal. We've got enough room there, so that's not a problem at all. It's the same value, 5.5 volts, 0.22 farad, I think it was. And also you can see all around here, there's some repairs here and up here. What has happened is the goop that came out of the old capacitor has gone onto the board, corroded it, and it's gone into the wires. So what I've done is I've drilled out the wires just with I think it was a 0.6mm drill bit on a little pin vise, like a little screwdriver kind of thing that you just drilled through by hand. And then I dropped some little bits of wire in there and soldered it on both sides. Before I did that though, I used, you can see it there, use one of these things. It's like a pen that's got this fiberglass bristles on the end. So I've cleaned all the corrosion off the board with that, brought it back to some shiny copper around the wires, and then yeah, drilled them out dropped those wires through and then soldered them up. Over here, I've just put a little jumper wire there because there was a 0 ohm resistor as a jumper, and that was all corroded up. So I've put that little wire there in its place, just to remove that corroded part and replace it there, so that we got that jumper still going on there. So that is all the corrosion and the part there replaced. So I guess all we can do now is put this thing back in, cross our fingers and hope it does something interesting that doesn't involve letting smoke out or sitting there inert. So I'll put this thing back in the unit. We'll press the power button and see what happens. Alright, so I've got the board back in here. We know we've got power coming to there. I know that the switch signal is coming into here because I traced that out all the way right to the pin. So now we've got to plug it in and turn it on. So I'll plug it in now. And we should get nothing. And we've got nothing because I haven't pressed the button yet. I'll lift this up so you can see the screen. I'll turn the lights off, just to make sure we can see what's going on. And if I press the power button, which is just on the left here, it's working. Hell yeah, I fixed it. That's awesome. Okay, next step is to feed some audio in and see if we get amplified audio out. I'll connect up to a speaker and see what happens, just to double check that. But it looks like it's functional. Look at that. Nice. Alright, let's see if it actually makes music. Alright, now for the moment of truth, the real test. I got a input cord here connected to my phone, and I have a single speaker hooked up to see if what I put in comes out. So I will rearrange myself a little bit here. I'll aim this speaker towards the microphone, and I'll do the same with the mic. So if I hit play, that's playing. We're getting sound. Nice. Well, I think that's a wrap. 2 thumbs up. Don't forget, keep watching the videos. Hit that subscribe button, and we'll see you in the next one.